Hi guys. So yeah, that was Tetris. Finally got some headway. Got that done. Um, a lot of work. Way more than I thought it was gonna be. It's been a couple of weeks, hasn't it? Um, so I just kind of wanted to show you a couple of things here. The first thing is, just so there's no question, the whole thing, the entire thing, is written in Turbo Pascal. Just took the basic code and ported it, and then went about adding features. Added the wall kick because that was missing. There's still not a floor kick. I'm kind of done. I've taken this as far as I want to take it. But basically, this is the original source code ported to Turbo Pascal for CPM, using PiGFX control codes to send through the terminal. Sounds done with a buzzer module. I'll put the picture up on the screen of basically what it is. Do simulated pulse width modulation using the CPU to create the sound effects. The entire thing is written in Pascal. Something like 1,500 lines of code if you count all the includable files. Towards the end, the source file got so big I had to turn off the error codes in Pascal to get it to compile, and it no longer compiles in memory. I added a couple of things. Basically, I wanted to use the collision detection within the terminal because it's supported. But the biggest problem you run into, particularly with a wall kick, is you need to do the calculation to determine if the piece is going to go beyond the playfield prior to drawing it. And so with collision detection in the terminal, the two hardware sprites have to collide. So because the walls will be drawn over by the time you get the collision, it's not very useful in this instance. Something like a breakout clone or a Pong game or a race game where you are literally firing linear pixels across the screen and hoping that they will collide with something, and you're trying to do detection, that will work quite well. But if you need to know if something's going to collide prior, you have to handle all the collision detection yourself inside the program. I don't know what it would take to add that to the PiGFX terminal, but that would be a really great thing, is if you could figure out if hardware sprites were going to collide prior to moving them, or if moving a sprite would cause it to collide with another sprite. That would be very useful. The other thing I did is I updated my graphics library to include a bitmap font. Basically, how the bitmap font works is it takes a file with the hex code. Each one of these lines is another font. So every two numbers or characters is a line. And basically what you do is you read those characters in, and when you put them back together, you get the bitmap for each character. This was Daniel Hepper. He did Marcel Sondar's public domain VGA font as a C header, and I took it and stripped all of the C header information off of it, put it into a text file that could be transferred to the CPM disk image, and then used that, loaded it in manually to get fonts. And the reason that I needed to do that was the font positioning on the color maximite. You can position fonts two ways, in rows and columns or in pixels. And the fonts that are built into the PiGFX interface, there's not a way to use control codes to position the fonts freely based on a starting pixel. The other thing that I did do, then I wound up not using it, was I wrote a line draw routine. You can see it's huge. Number one, it does a ridiculous amount of calculation, and basically it made the program run so incredibly slow, just simply because if you need a line draw routine that is exactly like the color maximite, you've got to be able to figure out how to translate that syntax into something that you can send as a geometric primitive to the terminal. And the color maximite uses a formula where you provide it two corresponding pixels, which are corners of the rectangle. So if you give it the top right one, we'll say, then you have to give it the bottom left, or the top left and the bottom right. And you can give them in any order you want. So that means that there's 4 different combinations that you have to figure out so that you can find out which 2 pixels you have, and then convert that into width and height information, because you have to send that to the PiGFX terminal. I wish I had shot video. It was very, very slow. And in the process of troubleshooting that, instead of using line draw routines to build the squares for the Tetris pieces, I ended up using 7 more bitmaps on top of the several 100 or so bitmaps I used for the fonts. I wish I had coded the rewritten the code for the line draw routines to use the primitives that are built into the terminal. I believe it probably would have run just as fast, but at that point I was probably 2 weeks in and kind of just ready to be done. So I did the bitmaps, and it worked out great. I don't use any hardware sprites, maps, and blanking squares that basically, when a piece is drawn, it draws each one of those individual little boxes. There's 7 bitmaps, each one for each of the different colors. It just works. I mean, basically, all we're doing is overwriting the area that you're moving from with a black square, and then you're putting in a color version of the square down slightly more. It works pretty good. I'm happy with the way that it looks. The other thing I added was, and I'm not doing so great here, when you reach 20 lines, it pops back to the next level of difficulty. I don't remember exactly how many lines you had to get in the Game Boy version of the game, but that's kind of what I was going off for that. So you can start at any level, but it will, once you get to 20 lines, it sets your lines back to 0, but then increases the difficulty until you get to the 10th level of difficulty, where it just stays. Until, I suppose, your score runs over the top limit of the integer boundary for Turbo Pascal, at which point the program will crash. But basically, that's my Tetris clone. Some obstacles I ran into. Number one, the computer itself has a clock, a real-time clock. I fixed mine, by the way. Found out through some testing that it wasn't really broken. Somehow the time had got unset, and the way that the PiGFX terminal works is if it doesn't see any ASCII characters after a certain period of time, it doesn't advance past the loading screen, which doesn't always come up. So then what happens is, when the clock's not set, there's a prompt that comes up that asks you if you want to load the compile time information into the clock. And you hit yes, and it begins to send characters to the terminal again. Had I known that, probably would have saved me some heartache. I did buy 2 replacement real-time clocks and took the resistor off one, so that I could put the battery in, but the ones that I got were just not good. There's no ifs, ands, or buts about it. They look compatible. They use the exact same layout. The chips are not the same. I'm sure of it. They're different slightly. They were very cheap. So that's what you get when you buy stuff from China, I guess. But I was able to get the original clock to work, and how I did that was I just read the documentation. So the Z80 MBC's sketch is very well documented. It's almost kind of like a manual. And I went into the sketch and I looked to see what causes the iOS light to blink. All the fault conditions, and the first one was the real-time clock. So I figured out, yeah, you gotta push yes, and then it works. But anyway, getting off on a tangent. The obstacle I ran into was there is no hardware timer that runs in the background in CPM or on the Z80 MBC, besides the real-time clock, which only has seconds resolution, that you can reset, that will keep track of the number of milliseconds that have passed, that you can use to set up timing loops where you're trying to do time elapsed. And is there probably a way to do that in assembly? I don't think, in parallel at least, because the CPU can really only do one thing at a time. So unless you're doing some really, really fancy coding to try to keep track of milliseconds as they pass, and do other things in between, I think it would be very cumbersome to do that, and far, far easier to just have a piece of hardware that keeps track of the milliseconds in the background. So that was one of the things I ran into, was the Color Maximite version of the program has a milliseconds timer that that basically tells you how many milliseconds have passed. You can reset it. There's a certain number of milliseconds that go by. I don't remember exactly how many, but it's a huge amount. And then it resets itself. You can add to it just like any other variable. So like if you wanted to set it to a certain number of milliseconds and then reference back at it to see how many milliseconds have passed, you could do that. I think that would be a great thing to add to this computer. I don't know if the Arduino that is in the Z80 MBC, if I could add an OP code to do that, I probably could. Maybe that's worth looking into. The other thing I thought about doing was, I still have a whole ton of pins available on the general purpose I/O. I could just make a custom PCB that has a timer circuit and add to it a buzzer similar to the timer that is built into the XT computer, or the 286, so that you can, one, control the buzzer without actually taking the reins and having the CPU be busy doing that. You could send a beep command or a pulse to the speaker, or a pulse pattern to the speaker, without actually having the CPU do it. So that would be very beneficial. You could create sound, have it start playing, and then continue doing calculations or operations inside the computer while the speaker is running. That would be very beneficial. It would be also good if you could use that timer to feed back information to the computer if you want to, say, figure out how many milliseconds have passed. So that's probably a thing I'm going to look towards next. The reason that having a timer would be good is the only thing I do with the real-time clock in the program is there is a almost kind of like a screensaver that comes up at the beginning, that after a certain number of seconds pass, the high score screen comes up, and then it pops back to the menu if you don't do anything. That was basically just put in there because I had spent time writing procedures and commands that access the real-time clock, and I kind of wanted to use it to show how it works within the code, because the whole thing about this project was I wanted to kind of show, you know, even though it may not be the most efficient way to do something on a Z80, it's still pretty powerful. Especially at 8 megahertz, you can do some fairly impressive things with very, very logical, easy to read code. But the way that I had to keep track of time was basically just counting the loops, which is very, very inaccurate way of keeping track of time. The first problem I ran into was the two different control methods. The joystick versus the the keyboard. You have to create all these offsets. There's a debounce delay for the joystick, and that makes the loops run slower. Just does. So you have to make the game run faster. That's what these settings are, to compensate. Well, then once you've made the game run faster to compensate, it's running too fast when you're using the keyboard. So you have to have another offset that slows the system down. And then, because you need a certain degree of precision, the timer routine had to be converted to a real number, which ends up taking slightly more memory. And when you're trying to make a Pascal program fit into main memory without using any kind of bank switching, which was a goal I had, you need to pay attention very closely to variables you're using, how much memory you're using, like particularly the bitmap fonts. If I wasn't able to load those directly into the interface over the serial port, I would have to hold them in memory on the computer, and that would take up a tremendous amount of space. So it's all about space. But anyway, yeah, keeping track of time passed using loops inside the program, the loops you're actually using to run the program, is probably a bad idea. Now, if you're trying to generate a delay, you can create a very accurate delay, because we know how long cycles are in the CPU. You can simply just figure out how many cycles you need to pass, and then you can get a very, very accurate delay. But in this case, we're not looking for a delay. We're looking to see how much time has passed. And so, because we need to do that, and there is no hardware inside the computer to make that work, you're kind of stuck. It was pretty long and rambly. I plan on working on, hopefully next weekend, getting all of this stuff up on GitHub so people can look at it finally and see some of these examples that I've created beyond just links that I've posted in my YouTube videos. I really hope that it will inspire other people to do similar things with their homebrew computers, particularly with Pascal, because it is a powerful language. And I think even though it is just a single pass compiler, and in terms of the machine code that it outputs, maybe C is slightly better, but if you're gonna do something like this, and you're gonna use a slightly higher level language, but still use a compiled language, Pascal's probably not a terrible choice, if you think about it, for something like this. Alright, well, I hope you enjoyed. Long rambly video. Maybe I won't wait so long next time to post something up, but I really, really wanted it to be very polished before I posted it up. I'm sure I'll find another thing or two while I'm editing the video that I need to change. But as far as me working on the Tetris clone, it has become a rabbit hole, and I think I'm kind of done. So, thanks for watching, and I hope you enjoyed it. Bye.